Okay guys, we're back at it. This is lesson H10, day 2. Now in day 1, the focus, the emphasis was on finding the inverse matrix. I did show you a sample problem on how to solve a system of equations with matrices, but I wanted to take you through it one more time. And the homework for this lesson is really more along the lines of solving systems with matrices. The last homework was really more about finding those inverse matrices. Okay, so I've got example SEAL Team 6. We've got a system of equations, and we're going to solve with matrices. Let's break this into steps. So, step 1, multiply both sides by the inverse of A. So, multiply both sides by the inverse matrix of A. Well, I guess to do that, we need to actually put this into matrix form. So, we have the coefficient matrix. We have the variable matrix. And we have the solution matrix. Notice the gap I left here, that was intentional. We have -5 and 20. Now we're going to multiply both sides by the inverse matrix. So that's A -1 and A -1. I had to put this in front because remember, multiplication of matrices is not commutative. Now we're going to have step 2. I showed you 2 ways to find the inverse matrix last time. We're going to use the easy way. So step 2 is go figure out what is the inverse matrix. All right, so let's remember that the formula for that is inverse matrix equals 1 over AD minus BC times the matrix. We have D and A in those corners, and these corners just change signs. Now, from our coefficient matrix, I know that A equals 1, B equals -5, C equals -4, and D equals -2. So we're going to plug those numbers into that formula. So the inverse matrix equals A times D, that's 1 times -2, minus B, which is, you know what? Yes, B is -5 times -4. Sorry, I thought I made a mistake, but I didn't. And then we've got D up in this corner now, so that's -2. A down here, and that's 1. Then we take B and change the sign, so that makes it +5. And we take C and change the sign, so that makes it +4. Now we have some arithmetic to do. So that's 1 over -2 minus 20 times -2, 5, 4, and 1. Okay, a little bit more arithmetic. So we've got 1 over, now that's -22. I like my negatives in the numerator. You do whatever you want on that one. As long as you do the arithmetic correctly, it shouldn't make any difference. Okay. So my final inverse matrix is 2 over 22, -5 over 22, -4 over 22, and -1 over 22. All right, now for right now, I see no reason to change these to smaller versions of equivalent fractions. I'm going to leave them the way they are right now, because who knows, I may want them all to have the same denominator later. Okay, so step 3, plug step 2 into step 1. So we're going to take this and we're going to put it in there. So now we've got 2 over 22, negative 5 over 22, negative 4 over 22, negative 1 over 22, times the coefficient matrix, which is 1, negative 5, negative 4, negative 2, times the variable matrix, xy, equals the inverse matrix again, 2 over 22, negative 5 over 22, negative 4 over 22, and negative 1 over 22, times the solution matrix, which was negative 5 and 20. See how easy this looks? Isn't that great? All right, now what we're going to do is, I'm 99.9% sure that the product of these two is an identity matrix. But I need to convince myself, because maybe I made an arithmetic mistake, you never know. So I need to convince myself that these two multiplied together are an identity matrix. If not, this whole thing won't work. So step 4 is to check your inverse matrix. And we do that by multiplying these together and making sure we get an identity matrix. So we've got 2 over 22, negative 5 over 22, negative 4 over 22, and negative 1 over 22 times, and the coefficient matrix was 1, negative 5, negative 4, and negative 2. And we're going to be doing R1 column 1, R1 column 2, R2 dot column 1. These are all dot products. And R2 dot column 2. So that's the multiplication we're going to be doing. You can see this is going to be a lot of fun with all those fractions. So we've got two over 22 times 1 plus negative 5 over 22 times negative 4. 2 over 22 times negative 5 plus negative 5 over 22 times negative 2. Then we've got negative 4 over 22 times 1 plus negative 1 over 22 times negative 4. And then we've got negative 4 over 22 times negative 5 and negative, this is plus negative 1 over 22 times negative 2. So we've got some arithmetic to do there. This is 2 over 22 plus 20 over 22. That looks promising because that's 1. We've got negative 10 over 22 plus 10 over 22. That's 0. We've got negative 4 over 22 plus 4 over 22. And we've got negative 20 over 22. No, it's actually plus 20 over 22 plus 2 over 22. So this equals 22 over 22, 0 over 22, 0 over 22, 22 over 22. And guess what? You've got your identity matrix. 1, 0, 0, 1. Check. Okay. Now that I know the product of these two is an identity matrix, I can plug the identity. Oh, let's write this out as a step. Step 5, plug in identity matrix and solve. Okay, so we've got the identity matrix 1, 0, 0, 1 times variable matrix x, y. Oh, let me clear up what I just did. So we had this, and I confirmed that this was the identity matrix. So I'm taking these two out and replacing it with the identity matrix. Equals. Now I still have this inverse matrix of 2 over 22, negative 5 over 22, negative 4 over 22, and negative 1 over 22 times the solution matrix, which is negative 5, 20. All right. Now at this point, I can show you this multiplication, or you can just trust me based on our previous work that the identity matrix times xy is in fact xy. Because remember, the identity matrix, that's just like multiplying this by 1, okay? So all I have left to do now is the multiplication of this matrix times this matrix. So what we've got is we've got 2 over 22 times negative 5 plus negative 5 over 22 times 20. Why did I put 200? I don't know. And then we've got negative 4 over 22 times negative 5 plus negative 1 over 22 times 20. Okay, let's just ignore the blob. Okay, so xy equals, we're going to do some arithmetic, that's negative 10 over 22 plus a negative 100 over 22, and this is 20 over 22 plus a negative 20 over 22. So xy equals negative 110 over 22 and 0 over 22. So we can just simplify that and see that xy equals negative 5, 0. So the solution to this system of equations is x equals negative 5 and y equals 0. So now you got another example on how to solve a system of equations using matrices. This way, much easier than what I showed you last time, because we're using the simplified formula to find the inverse matrix.